Here I have a React with Vite client-side rendering application that is simulating fetching 2,000 records of Taylor Swift lorem ipsum data. I am using React's built-in suspense component and React's lazy function, a function that returns a promise or a promise-like object with a then method. I am also using the error boundary library available from NPM repository, which we need to use when implementing suspense with the lazy function. I will go through all of that relatively quickly because there are several million tons of video about that subject already. I will focus on Vitest unit testing, the error boundary, and suspense, which many of you have been asking me to do. As a reminder, I have a video covering setting up a Vitest with Vite and React apps. Starting with a bare bones project, I am of course using Vite. I am using Biome instead of Prettier and ESLinting. Biome does the work of both. I am using pnpm instead of npm because pnpm is faster. I've aliased the command pnpm, which is np, in my G's configuration file. You can do the same if you wish. Now, if you notice here that in the Vitest setup, in my previous video, I used the naming convention of vitest.setup.js or ts. Here I'm using setup test camel case because in the future, if you decide to go to some other new Fandango, fancy, super fast 10x unit testing framework, then you know where the setup tests are and it's platform independent. The React error boundary is very popular in the React community. It has good documentation and community support, and as you can see here, it's popular. As a quick reminder, because a lot of you guys know this already, but the React documentation tells us that the pattern for using lazy and suspense, we should use it together hand in hand. We create a separate component for the part that's going to be lazy loaded. Then we call that component within the lazy callback. And then we wrap that lazy component around a suspense. Now, out of the box, React does not give us anything out of the box for error boundary, but it does admonish us to have some sort of error boundary, and we need to create that on our own. So that's why we're using the library, because it's a proven technology. Now I'm calling this project Bacon Cabbage Vitest because it's St. Patrick's Day when I'm making this, and I like having Irish bacon and cabbage on St. Pat's Day. Anyhow, so please create just a skeleton data component along with a data test component, and then of course we'll have our lazy component. Create one of those, which is empty shell, and then create the equivalent testing um, file for it. And of course, you can pull down the skeleton for the retest setup. And I know that you guys code and test in parallel like all good software engineers, right? I'm going to start out in the data.js component because I want to highlight an issue that I've seen happen a lot. And like, I mean a lot. And so many people have asked me this over the years. And the issue is this. So back in the day, you had to import the entire React library to use one of its module. For example, if you wanted to use lazy, then you have to import lazy and then call it like this, react.lazy. Well, In modern React, you don't have to do this anymore, and you don't need to import the React library on every single component, which is a waste of bandwidth and time. And so you can destructure the import out with just lazy. Now, if you do that, um, then what's going to happen is that the test is going to fail. The V-test is going to fail. And the error would be something like missing React import, when in fact in your test file you already imported React. The issue is that you need to add React. So within the defined configuration object for the plugins on line 5, you need to add React, instantiate React in the plugins array to stop that error from appearing in Vitest. So remember this. If I'm not sure how to make this an important part of this tutorial, but this is, if you forget everything I teach you in this video, just remember this part of it. If you get the nonsensical missing React import error in your Vitest. Now that we have that out of the way, let's work on the lazy component in lazy data, and then work on the equivalent testing file. We'll scaffold out the unit test for lazy data. We'll import um, our testing library and render and screen, and then we'll of course import the module itself, the component itself, to be tested. And then before each test, what we want to do is we want to render the component that we're testing. That way we don't have to render this in every single test that we do in this file. And of course, in our setup, we've already telling the testing framework, telling Vitest to clean up after every test. Now, if you are a full stack developer and if you do Java, if you're doing Java programming, for example, in IntelliJ, okay, in IntelliJ, I highly recommend that you work on the front end portion of the app using VS Code, and then work on the Java stuff in IntelliJ. Okay, especially if you have a mixed team, if you have a mixed team of front end and back end dev, and if you're not familiar with VS Code, in VS Code you can open up multiple consoles at a time. For example, in my package.json, I have the command test and def in my script, right? Test and def. And so what I can do in one terminal, I can do like pnpm run dev. Of course, I don't have anything yet, but you can click on this plus icon here, have another console, and then do npm run test. Okay, and then you can, of course, it's going to fail now because I don't have any tests. But that way you can monitor your tests, and of course, you can also do like a live reload setup as well if you want to. But this certainly is an option for you. What I meant by that is you can set up Test Watcher as well. If you're coming to JavaScript from a different language, the way that I generated the 2000 records is that I declare an array, pass in 2000 elements with nothing. So I have, at this point, I have 2000 undefined arrays. And then because it's an array, I can run the native higher order function map on it. Now map takes an element as its first argument and index as its second argument. Since I don't need the element, I'm just give it the underscore but I still need the correct order, right? So I'll give it the underscore. That's what the underscore is for. Now I'm going through this because instead of using the index for the key for React to do is virtual DOM on, I'm declaring a unique key to have consistency in the React virtual DOM. And all this gibberish here is just to create a random 9-digit character, and I append the random 9-digit number to the index. That way, it's unique. It's always going to be unique, and that way we have consistency when we render data in a real app. To generate the different background colors and the styling for each record DOM element, I've added this styling here. Now, these styles can live in its own separate CSS file. except for this one here, because we need to interact with the DOM. So we need to do a little bit of math here to generate the dynamic coloring. So this needs to stay here. And then to generate the Taylor Swift lorem ipsum, I went to a website that has automatic Taylor Swift lorem ipsum generation. And of course I added the index to make it dynamic. Now that we've generated the records, let's return the records here. Now that we have the basic component in place, let's write our first test. So we should have a record of 1, right? I know that is 0 index, but that's why I added the 1 to make it a record 1. A record of 1 should appear somewhere in our UI. So the first test, very basic, should look like this. I want it to render without crashing. So get a first element. Since I'm bringing in the screen up here, the screen, get text, get my text. It should have record 1 in the UI, right? So then let's test this to make sure that, let's run the test to make sure that it's working, it's passing that test. This is just like a, smell test to make sure everything's working. That test part, obviously we haven't written anything for data yet. We've only worked in lazy data. So, all right, so we're good to go there. Okay, so the next test, because I am loading 2,000 records on the first load, right? 2,000 records on the first load, on the initial load, I want 2,000 right away. 2,000, by the way, 2,000 for Swifties, that's like a drop in the bucket, right? So I want to make sure that I'll get the first 2,000 record first, right? Okay, so that passes. Next, I want to make sure that all the records have unique keys, because potentially there can be like millions of records in the UI, right? So I want to make, that's why I created that unique keys, so that I want to make the records to stay consistent. Consistency is part of the ACID compliance for database. ACID compliance, ACID. Those are abbreviation. And consistency is the C in ACID compliance for databases. Anyhow, so I'm using set here. Set is one of those things that you can use to remove dupes. Um, I have a tutorial on how to use set in one of my short video. We're not done with the lazy data component yet, though. Remember earlier in the video when I mentioned that we need to add uh, error boundaries to Suspense? What we need to do in this component is to set some sort of simulation to where we can simulate an error uh, during lazy loading, so that we can test the um, error boundary when in development. So to that end, we'll have a simulate error constant, which by default would be false, of course. But if we were to flip this to true, then we are going to throw a simulated error so that we can test the error boundary. So now in the data component, we will bring in error boundary library. And then I know some of you guys are really upset that I renamed bacon to lazy data, but then we'll load the lazy data by utilizing the lazy function, right? And of course, with a callback. Now, you have to declare this outside of the component itself, right? Like this. I know this is mentioned millions of times already by other people, but just in case you're new to this, declare this outside the component, please. And then in the JSX, we return the lazy data component surrounded by suspense and with a fallback. This is a bit of comedy, but for your fallback, it could be a separate function as well to do something more complex. But we're not done here yet, obviously, because we haven't used uh, error boundary yet. We need to wrap this entire section inside of error boundary. The error boundary takes a fallback component as its prop. So therefore, we can pass in a fallback function. Now I've declared the error fallback function here, but you can certainly declare this function anywhere in your code base and then of course import it in. And I'm using a function expression instead of function declaration only because since I'm using this function after it's been declared. I don't need the hoisting. The parameters in this function are error and reset error boundary. The error parameter is so that we can run it out the error message in the UI, and then the reset error boundary is to reset the error boundary so that we can re-render the rest of the components within the component tree. Before we test in the UI, let's scaffold out our unit tests for data. So we're going to mock the lazy data component, or we're going to import it as a module. So that's why we're saying that use ES module to be true. And then by default, we're going to throw the error in lazy data component so that we can test to make sure that everything is working like it's supposed to. And then for the test itself, we can just go ahead and render the data component just one time here so that we don't have to render it in every single test. I want to see the error boundary in action in development environment. So therefore, in the lazy data component, I am going to flip the simulate error to true, save. This is what it looks like when the error boundary is triggered to simulate an error. Now, of course, this is the error message here. And of course, the reset error boundary is tied to on-click event for this button. Now, in your own application, you can either have this re-render the component tree or do something more sophisticated. And of course, it goes without saying that you need to add the data component within your main. And don't forget to flip this back to false. So we have the suspense with fallback here. Let's test them to make sure that we have a fallback. So in the unit test file, let's write our first test, very basic here, right? You guys have seen this before. As you can see here, the first test, I'm running the app and I'm running the test at the same time. Okay, so it's passing. For the next test, it will make sense as to why we are bringing in the lazy data component and then mocking it up here and then throwing this test error. Because the next test will simulate, as the comment indicates, that we are simulating an error state with an error boundary. And so we expect the DOM element that's alerting us to the error, the role would be an alert, and it is right there. And then something went wrong text should be in the document, because if you recall, when the error boundary is triggered, we have the something went wrong text at the top. And then get text test error, because we're throwing the test error here, right? So when we trigger this error, we're throwing this new error. Okay, so that's legit. And then we are going to the screen and then getting the button to make sure make sure the button says try again. This isn't, case insensitive. That's why there's a bit of regex there to be in a document, right? Now, this condition, this test will also cover the case where if you have a developer on the team that is testing out error boundary and they flip this to true, and they forgot that they flip it to true during development, um, and not flip back to false, it'll throw an error as well, and the uh, it will fail the unit test so that they don't check in code that they're not supposed to check in. One way to test this is we can build a command by running p npm build. Of course, my p npm is alias to just pn. So I build this out, it go through this gzipping process, and then I give it the command npx serve -s dist, because when you run the build command, it'll generate a dist directory for you. And I want it to run on port 777, I'm sorry, quadruple seven, right? My lucky day. And then of course it's running the built app for me. And then in another terminal session, I can run just like the unbuilt local development environment application for comparison. So now I have the built app and the local development app running. Obviously, the built one is on port quadruple 7, and we can tell that it's been gzip and minified. And then the lazy load, uh, the first 2,000. Remember, we lazy loading the first 2,000 record on the first load, right? Um, as you can see here, it's being chunked out for us. I'm sure you guys have seen this on all the channel already, but I'll go through it. The size is 1.8 kbs, and in development is 13.8 kbs. And if you notice here, I've disabled the cache so that it doesn't cache. Well, you can say that, well, my app doesn't cache anything. Well, your app might not cache anything, but the browser is going to cache certain things. So this option is just to avoid having to do one of those. Okay, and then you can also simulate like a slow internet connection. I won't do it on this side because it'll take forever, but you can certainly do that, and then you can watch. You can watch the Taylor Swift is coming for us all. Ah! But anyway, so there you go. I will have a completed project repo for you on GitHub. Sadly, I won't call it bacon and cabbage. It'll be called React Vitest Lazy Loading Error Boundary Completed. A nice and short title. Okay, my friends, I hope you appreciate my humor. Hopefully, I make your day a little bit brighter. Thank you for watching. Please consider subscribing and giving this video a thumbs up. I'll catch you next time. Bye for now.